Everyone, welcome to the video. Today we are going to solve what are the plants. So in this question, we are given a gallery of range n, okay, and we have to return whether this gallery can water all of the range or not. So will tell you briefly. So here, any index I can water to its I plus current element index value and I minus, which means if we are at this index 1, the value of index 1 is 2, so it can obviously water for two indexes prior to it, which means all of the indexes prior to it in case of index 1, and two indexes after it. So what is that? So if we check integer index 1, then its value is 2 obviously, and it can water two previous indexes. Here we have only one index, so it will eventually water it, sprinkle it, and two indexes after it. So what? So two indexes after it means this index 2 and index 3 also. So index 1, which with value 2, can range up to this one, index 3. Okay, this is what it means. If there is any value of any of given index, it can water up to, it is given over here, yes, I plus x to I minus x, and x is the value of that particular index. And we do not need to discourage with zero. Zero means it can water for itself but cannot water for prior elements or afterward elements. Okay, so we have to return the, the minimum number of sprinklers which we need, okay, so that we can water the entire gallery. So see in example 1, if we turn on the index 2, which is 2 over here, so it will water for two prior indexes and two afterward indexes till index what? Index 4. And if we eventually turn on the index 5, it will water for itself, and index 2 was able to water for other plants in this gallery, which means it this gallery can be sprinkled completely, and with the help of two such sprinklers, hence we return 2. But if there's no possible way to learn full length, we can return -1. So see in example 2 over here, we have 9 number of elements in this gallery array. Okay, now if you can turn on any, let's say this is index 2 is having a 4 value. If we turn on, it will eventually water all the elements prior to it, 2 and 3, index 0 and 1, and 4 elements prior to it, okay, afterwards. So -1, 2 and 0 and 0, this one can be watered. Okay, this one can be watered. But since this index, okay, this index cannot be watered. See, this index 7 is having -1. See, this 4 was not able to reach this index 7. Index 2 was not able to reach index 7 because it will only reach 2 plus what? Value x, value 4. 2 plus 4 is 6. Index 6 is 0. So here it till here it can reach, but index 7 is -1. -1 means it can neither water itself nor to any other neighboring rows. So this index 7 cannot be reached by any means. Hence we cannot water the entire gallery. Hence we will return -1 as the output. And see example 3 also. Again we have 9 elements. Now if we turn on the index 2, which is 4 again over here, so it will be able to water all the prior indexes, and since it is index 2, 2 plus 4 6, so till index 6 it will be able to water till index 6. So this range is covered. Okay, this range is covered. Now we have index 7 is 0, so it will be able to water itself. Then again index 8, it will again be able to water itself, though they will not be able to, like index 7 being 0 will not be able to water its neighboring element, which is index 8, but it will eventually water for itself. It will do the job for themselves, which is why we'll consider it, and again consider index 3, sorry 8, and this is, and see index 2 was able to water for all these things, all the colored ones, and index 7 for itself, index 8 for itself. Hence we have return 3 because we need 3 sprinklers to water the entire gallery. Now, how will I approach it? So to begin with, just give me a second. To begin with, I will create a list of tuples which will represent the range up till where a particular index can water for itself. Okay, and now, and I will order it in decreasing order. Okay, so I will create a ranges, okay, which will be sorted, obviously sorted in decreasing order, and it can so okay. So as we mentioned, a particular value x can water for I plus x and I minus x. Okay, I plus x and we'll say I minus x and I plus x. Okay, so previous prior ones and succeeding ones. Okay, let me enclose them first of all because these are indices. Okay, now for I comma x in enumerate enum enum what gallery is our input. So it can order for I minus x previous and I plus 1 succeeding ones for ix in gallery. Okay, but there is a condition. If gallery, let's say no, gallery not x not equal to minus 1, x should not be minus 1 because if x is minus 1 it won't be able to water for any other thing. It can neither water for itself nor for prior ones and succeeding ones as we have learned so far. And at the end we will reverse it in decreasing order, reverse it. Okay, now I will create three variables: current position, then max reachable position, and then sprinkler count of sprinklers which we need. Okay, so at the end, now we'll check while current position we have not reached the end of our gallery, we have not reached the end of our gallery, and we will check if there is a particular range to begin with. And I mean ranges means there is an element over there, and the last element in last range is reachable. If the last range is reachable and there is an element, we can go ahead. Then I will create two variables, beginning and end, start or end. So and these they will store the what they will store the popped out elements of ranges. Okay, so I and j, I and x. Okay, I will be the current element, I mean to begin with, and x will be the range. Okay, so it will store the not range but in the last index till which it can water. Okay, so like let's say here it was 4, so index to I will to beginning will become 2, which is the index value, and the end will become 6. Okay, now if that's the case, I mean if there is a range and the current range is reachable to the current position, then we have found a new maximum reachable position. And if we have found, then we will we if we have eventually found our current max position, then we will swap it with the n plus 1 because that's till where we can reach finally. Okay, if that's not the case, if we have not found it, then we will check if the maximum reachable position till here, if the maximum reachable position till here is greater than current position. I mean if we are at current, let's say index 2 and we can reach till index 6, then we do not need to worry about till for index 2, right? We have to think about index 6. So we will replace it with max reachable position because we do not have to is put efforts for index 2, we have to think for index 6 in case of example 2 and example 3 also. Okay, and we will eventually increase the sprinkler count by 1 because we have we are able to cover this particular range, we are able to cover for this particular given range. Then at the end, if there is no element and the current element is not reachable, or the current range is also not covered, in that case we cannot do anything and we will return -1, which was in the case of example 2 and index 7. Index 7 was not reachable. Okay, index 7 was not reachable by any means. And at the end we will return sp count. At the end I will return sp count. Okay, yeah. If it was able to, if it was able to reach, and we are able to sprinkle all the elements in the gallery, then we can return at the end that yeah, we need this much minimum number of sprinklers in order to water the entire gallery, entire row. And let me submit it for you. uh, yeah, it does the job. It does the job in pretty less time. So as you can see, my accuracy is pretty bad because it took me a lot of attempts. And so it may appear at the end that it is simpler, but it is not. It is quite complex. And because I thought, I came up with a mind that we will need greedy approach, but at the end, I mean, there were a lot of hidden things which you need to, hidden cases, edge cases which you need to care, and you may be able to understand using these so many conditions. So I hope you enjoyed it. Thank you. Have a nice day.